In this video, we'll discuss guessing formulas for derivatives. So suppose we have a function like f of x is equal to, say, e to the x, where e is the usual 2.718, blah, 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 blah. Okay, what is the formula for f prime of x? What is it equal? Well, some of you may know this already, but suppose you don't, and how could you estimate it using some computations? Well, I'm going to take some sample values and see if I can see a pattern. So I'm going to fill out a table of values. Let's start with, say, 0, 1, 2, and 3. And let's suppose that we have x as each one of those things, and then we want to figure out what's f prime of x in each one of those cases. Well, we can numerically approximate the values of f prime using the average rate of change formula, and we can take very small intervals to do this. For example, to figure out what f prime of 0 is, well, it's going to be very close to the average rate of change over the interval between, say, 0 and 0.0001, say. So I'm going to use the interval. I'm going to look at f of 0.0001 minus f of just 0. Now this is a small interval, right? The difference between 0 and 0.0001, that's really small. And that'll give me an estimate on what this derivative is. So if we plug these things into our calculator, we find that e to the 0.0001 minus e to the 0 divided by, well, 0.0001 is about 1.000100005 minus, well, e to the 0 is just 1 divided by 0.0001, and that's about the same as 1.00005 0.000167. Okay, using my calculator, trying to keep as many digits as I can. Let's just call that 1. That looks really close to 1. So I'm going to say the derivative of f, if f is e to the x, is 1 at 0. Okay, so that's an approximation for what happens at f prime of 0. What if we change this now to f prime of 1? So I'll put a 1 in here. Instead of using 0 to 0.001, I'm going to use from 1 to 1.001. That's a really small interval that includes 1. So again, here the interval starts at 1 and it goes to 1.0001. And then I take the difference between those two things. And now I'm taking e to the 1.0001 minus e to the 1. Okay, so now I plug those into my calculator. And what I find is that e to the 1.0001 is about 2.718553670023. Okay, that's this part, and then minus e to the 1. E to the 1 is same as e, which is 2.7182818286. And then I divide by 0.00001, and that'll give me 2.71841708. Okay, so that's my estimate for f prime of 1, that is the derivative of e to the x at x equals 1. Now, the thing to notice about this, and this is kind of crazy, is look, this number is about the same as e. So I'm going to make a guess. So this is where the guessing game comes in. I'm going to guess that, in fact, the derivative at 1 is e, because what I got out of the average rate of change formula was so close to e, it seems like more than a coincidence. That's my guess. Now let's look at what happens at 2. What is the derivative of f at 2? Well, I do the same thing, but now I use 2 instead of 1. So the derivative of f at 2 is the average rate of change over a very small interval, including 2. And that's going to be the same as e to the 2.0001 minus e to the 2. Here I'm using the interval between 2 and 2.0001. Difference in the denominators is still 0.0001. I plug in things into my calculator. And what I get in the numerator, to e to the 2.0001 is approximately 7.38979950449. In the numerator, still I have now 7.38905609893. Okay, then I take that difference and divide by 0.0001, and now what I'll get is 7.38942556407. Okay, and now what I see is, look, this number is about the same as this number here, right? It's also about the same as this number. All these numbers, these three numbers, this, and this, all start with 7.3897, or 7.389, which is, well, what is that? That's very close to e squared. So in fact, this is approximately e squared. That's the same as here. So for 2, I'm going to just take a guess and say that's e squared. Okay, then we do the same thing for 3. And what we'll find after doing the same process is we'll get something like this. This ratio is going to be about 20.0875455,773 minus 20.08553,69232 divided by 0.0001. That's if we're working with 3. So these numbers, what I've put in here is 3.0001 and E3. That's a very small interval around 3. And the number that comes out here in that case is going to be 20.08654,12336. Now again, this number is close to this number and that number, and those numbers are both close to e cubed. So in this case, I get something close to e cubed. So my guess is that this should be the same as e cubed. Okay, so now I have enough to go make a guess for the entire function, a formula for the function. Look what the pattern is. For 3, I get e to the cubed. For 2, I get e squared. For 1, I get e to the 1, which is the same as e. And e to the 0 is the same as 1, so I can replace that 1 by e to the 0. So what we see is that f prime, no matter what x is, it looks to be the same as e to the x. That's my guess.